state.
Theories.
Yes.
But they don't work in quantum mechanics.
Okay. Yeah. Well, we're going to come to that. We're going to come.
You're not going to stand like that for long, so sit down.
Yeah, sit down.
Hurt your back.
Right. So, as what's your name? Emmanuel correctly states, there are actually several assumptions of these theorems, and one of the biggest ones is that it doesn't include the effect of quantum mechanics. Okay? Quantum mechanics is the science that describes subatomic particles. Okay? Now, for the most part, certainly for big things like planets and galaxies and superclusters of galaxies, you don't need quantum mechanics. You only need a classical theory, i.e. general relativity, Einstein's theory of relativity, right? So you don't need quantum mechanics. However, if the Big Bang theory is true, the entire observable universe becomes smaller than an atom, and then you do need quantum mechanics. And these singularity theorems don't include quantum effects. So what we would need to see if those theorems are really true, to see if the Big Bang really was the beginning, is you would need what we call a quantum theory of gravity. Okay?
Which involves string theory.
So string theory is one example, but there are others. There's another one called loop quantum gravity.
Yeah, I kind of heard of the string.
Yeah, string theory is the most famous, but it's not the only one, right? I've actually made films with the guy that invented string theory and the guy that invented the rival theory called loop quantum gravity. Now, what's interesting, and there's another one called Hijava-Lifshitz gravity. Now, what's interesting is that all people have tried to develop these theories and see if the Big Bang is really the beginning of time or not. And what they found is, in these theories, it appears that the Big Bang is not the beginning of time.
No.
That the universe existed before the Big Bang.
Okay.
Okay.
This is what they come with now.
Yes.
So this is but all that time they've been believing that.
Believe what?
They've been believing that the universe came into.
Yeah. A lot of people did believe that.
Okay. Now that has changed.
Yes.
And that will change again.
Maybe.
And it will always change.
Well, I wouldn't say it would always change.
No,
we'll get to hang on.
Yeah.
What would happen when we hope is that we'll get to a point where our theoretical description of the early universe will have evidence that is so strong that we will be confident in it.
So what would that evidence be? Like that it came from nothing?
It
came from nothing?
No, not necessarily. It may be eternal. Who knows?
No. But how? Where is your evidence that's eternal? Infinite?
I say we don't know at the moment. So at the moment, what we can say with confidence, we can trace the evolution of the universe back in time to about at least 1 second after the Big Bang.
Okay.
As we get closer, less than a second, things are less certain. Okay. So we haven't validated necessarily what happened, at the Big Bang itself. So we don't know what happened there.
Exactly.
However,
but the Kalam argument says that they say you don't. You say you don't know.
Correct.
The Kalam argument actually says that. So I'm just trying to find out what do you mean it's weak because let's open the verse. What verse is it?
In chapter 52, verse 35, basically.
Chapter what?
52, verse 35, basically.
32.
Before we get to that, I just want to ask you, what's your background? What's your name, first of all?
My name's Phil.
I do for you. Okay, so we're just sitting down casually here to discuss.
Well, probably you want to. How do I know any of this stuff?
What's
right? So I studied astronomy at University College London, and I'm not a professional cosmologist. However,
cool.
I do make films with professional cosmologists,
like Stephen Hawking and these guys.
Yes. Yeah. We've made films with a lot of the scientists that a lot of the people.
One of their students, in that you could say.
He's already in the field.
Right, let me ask you a question.
Yeah,
just because it's interesting, we've been focusing on the Big Bang. Yeah.
Yeah.
That's fine. You could do that. I mean, I'm not sitting here and saying that it's a tenet. You have to understand our position first of all, right?
Sure.
As Muslims, first of all, we're not compelled to believe in all the formulations of the Kalam cosmological argument.
Yeah, I understand.
First of all, like, the Kalam cosmological arguments from a philosophical perspective, it takes different forms.
Yes.
The most simplistic one, which is being popularized nowadays, is the one to be found in Ghazali's book Tufahat al-Falasifa, which is a book which is an argument that's popularized by the likes of William Lane Craig on a popular level.
Yes.
There are other such arguments like this, but Thomas Aquinas has like a 5 or 6 stage process, and he goes to the unmoved mover and stuff. So we're not saying that the Quran endorses all of that.
No, I know
we can't
that.
say that.
I know that, but certain Muslims do.
Do you get it?
Right.
So I'm saying that. So just as a preamble here, as an important point to start, or a caveat, that even if we say, okay, look, you've completely. I'm not saying this is possible. I don't think you could be like that, or even prove that it's possible. Well, let's just, for the sake of argument, that if the time came where you say, okay, I can completely dismantle the Kalam cosmological argument, it doesn't follow that then you have disproven God.
No.
Okay,
I wouldn't.
I agree with that.
I totally agree.
Second point, as I wanted to ask you now,
Yeah.
because you're kind of a specialist in this field. could you tell us the significance of the second law of thermodynamics?
Sure.
Okay.
Yes. As it applies to this discussion. Okay, so the claim has been made that that even if you forget about the Big Bang, the second law of thermodynamics proves that the universe is not eternal into the past. And that claim
is it what? Could you explain?
Okay, so sure, I can explain what the reasoning is.
Yes.
So the reasoning is that entropy is increasing into the future, and you'll get to a point where there's a maximum entropy.
Explain to them what entropy is.
So entropy, there's a rough definition of entropy, which is basically disorder, but that's not the precise definition of entropy that scientists generally use. The very precise definition is it's the number of microstates that you count with a given macro state. So let me try and explain what I mean by that, because that may not be apparent what I mean. So imagine you have, I'll try and give an example, right? Imagine you build a sand castle, okay? There's only one way, let's say, that you can arrange all the sand to make the castle, yeah? And now imagine you have just a pile of sand. You could rearrange the bits of sand in many, many different ways and still get a pile of sand. But there's less ways that you can rearrange the sand and get a sand castle. So we would say that the sand castle is low entropy and the mound of sand is high entropy. It's not exactly that it's disorganized, although people often use roughly it is that, but it's not precisely that, because there are actually exceptions where you can be more organized and high entropy. But generally speaking, the specific definition is it's the number, therefore, of microstates that you count for a given macrostate. Okay, so the idea is that entropy is increasing into the future, and it will get to this point where there'll be some maximal entropy, where there'll be no usable energy in the universe.
What would happen?
So in that sense, the universe would just be a very cold, diffuse gas. Yeah, and it wouldn't have any usable energy.
Okay? So how does this apply?
So how does that apply to the collapse? So the argument that's been made is, and therefore we can't have an infinite past because we would have got to that point, and since we're not at that point, then the past must be finite. Now the reason that this argument, there's a number of reasons why this argument is invalid. Okay?
But then you've got to qualify that it's invalid in your opinion.
Okay, it's not just my opinion, it's in the opinion of many of the people, the scientists, that have been quoted by the defenders of the collapse.
That's fine. There's people,
so let me just give you the context. No, don't take my word for it. I've made films with the very scientists that have been quoted by the people who are the top scientists in the field, that have been quoted by people like William Lane Craig. So Alan Guth and Roger Penrose are two of the key scientists here, right? And both of them agree that the universe is probably eternally into the past, and they've been misquoted when it comes to entropy. Okay?
No, you're saying so they've been misquoted by William Lane Craig,
and others. He's not the only one that's made this argument.
So what we're saying, just to qualify,
I know you're not necessarily.
There's no consensus in the scientific community, just to be clear. That basically
that entropy implies the beginning of the universe. Let me try and explain why, because so far I've only explained why it does. So let's try and explain why it doesn't.
Go on.
Okay. So first off, it's not. This is an argument made. There are different arguments about this. So there's not a consensus about this.
Of course not.
So there are different arguments. We don't know what the right answer is. So what Alan Guth has suggested is that the maximum entropy of the universe could be infinite. Yeah. In which case,
where's the evidence for that?
Hang on, I'll explain. Hang on, 1 sec, right? So if it's infinite, then you'll never get to the maximal entropy state. Yeah. And in a multiverse, that would be the case. Yeah, because although
in a
pocket,
but here now because to be fair here. Phil.
You Phil? Yes.
Sorry, we can't jump from one speculation to another. Because
with gravity they can.
Okay, so when you say speculation, exactly what do you mean by speculation?
Flat Earth, that's a different one.
No, I'm saying with gravity is on a different dimension. They can.
Just 1 second. What I'm saying is that.
Speak a bit louder, buddy.
Sorry, bro. What I'm saying is that generally, now you've mentioned the multiverse.
Yes.
Now I have to be honest with you here. We can't take that as we can't run with that at the moment. Do you get it? Like you can't just say in the multiverse, in a hypothetical, conditional,
science doesn't run with
multiverse.
Science,
this X, Y, Z.
It can't run with it because is it a proven fact?
It's not a proven fact, but it doesn't mean there's no evidence for it.
No.
Okay, so it's not like you're either proven fact or zero evidence.
The
You can have
multiverse,
something
for me is like religion. Believe me.
Why do you say that?
Because basically, why do you not believe in religion?
Because I feel the evidence for it is
okay.
God. Let's be the creator.
Okay.
Religion, we can.
You feel like the evidence for it is insufficient. It's lacking. It's not there.
correct.
For a creator.
Okay, so anyone can say the same thing about the multiverse.
Okay, so first off, let me address this point. Okay, there's two ways to address this. First off, even if we don't know whether the multiverse exists or not, we can say that if there is a multiverse, what are the consequences of that?
No, we can't say that.
Why not?
I'll tell you why you can't say that. Now, because now you're moving from science to philosophy, and it has to be shown, yeah?
Okay.
The reason why you're moving from science to philosophy...
I'm not moving from science
No,
to
you're
philosophy.
100% moving from science to philosophy.
No.
The reason... Okay, how do you define science? Science depends upon tangible, empirical findings in the known universe that we can use our five senses to take through the scientific method. You've moved from this, and this is... I'm not accusing you of this, but this is what a lot of people do, like Richard Dawkins, etc. They move from easily from science to philosophy to try and kind of slyly impose their view in the guise of a scientific argument. It's not a scientific argument.
It is a scientific argument.
No, it's not. It's a philosophical argument. So you've moved from talking about the universe and its beginnings, which we can talk about here from a scientific perspective, to talking about the multiverse. What I'm saying to you is, with the
you're
multiverse,
saying that's nothing to do with science?
Yes, absolutely nothing.
Why
to do with
is it
science.
nothing to do with
Because
science?
the multiverse is that which happens outside of the known universe. Yeah.
No.
No, what do you mean no?
Let me try and explain. Let me try and explain.
Explain to me how.
Okay, I'll explain to you how I think
something
you're
that happens outside of the known universe.
Okay, all right. So first off,
stop talking about gravity, man.
Gravitons are outside the universe.
I'll try and explain. No, hang on.
Am I wrong?
No.
Okay, well, let me try and explain. Let me try and explain, right?
Go ahead.
So, first off, I think what you're saying is that
Go on.
the multiverse is not science because these other universes are outside of our observable universe. But that doesn't necessarily matter because there may be traces of the existence of the multiverse in our universe. And if that's the case, then it is legitimate science.
Okay, you said once again, the operational word you used there is might be, isn't it?
Yes, and let me try and qualify that. Let me expand on that. So first off, so then we can ask the question, well, is there any evidence of this multiverse that we can observe in our current universe? Okay.
What do you consider evidence, just to ask you?
Okay. Well, if a theory makes a prediction and then we go and get data that matches that theory, then I would say that's evidence of that theory.
Flat Earth theory that this man believes in, that's fair enough as evidence.
Completely wrong. I'm saying I was talking about the whole concept.
Okay.
I'm just saying.
Sorry.
For example,
I think the evidence for a flat Earth is not good, and the evidence for it's a bit more like a sphere.
It seems quite good to him.
The way you've defined
it is good to him,
and he has maybe some kind of
right. It's not good. Okay, I think let's stay on the topic.
No, because I'm just the reason why it's important. Why are we defining evidence as that?
Well, how do you define evidence then?
Okay, for me,
this is how science defines evidence.
How does science define evidence?
We think that a theory is likely to be true, or it has evidence in its favour if it makes predictions for experiments, and then we do the experiment, and the experiment returns data that is exactly what the theory says.
So you're talking about the scientific definition of evidence?
Yes.
Okay, let's run with that for now.
Okay. So let me try and explain without right what the evidence is. So when we look at the Big Bang, okay, we see that there are a number of problems with the Big Bang theory, okay, and these can all be solved if you introduce something called inflation to the Big Bang, which is a hypothesized very rapid growth spurt for the early universe. Now, inflation makes a number of predictions for the statistical properties of the cosmic microwave background, which is the earliest light that we can see. Okay. And I interviewed the guy that was the cosmologist who gave the press conference for the European Space Agency's Planck probe, which is a $1 billion satellite that made the most accurate maps of this radiation. Okay, and I asked him, does your satellite provide evidence for this theory of inflation? Okay, and the answer he gave was yes, it does. And I'll give you an example. There's a number, I won't go into the technical details, but there's this number called NS, and the inflation theory predicts that you should observe NS to be 0.96. Okay, so when the satellite went and observed this, the observed value came back as 0.96. Okay, So we think, therefore, that the theory is somewhat confirmed. Now, of course, we would like more evidence.
Yeah, of course.
Okay, but so far the evidence has come back in favour of this theory.
What's your proposition?
Okay, let me finish it. Right now, this theory of inflation doesn't just predict these properties of the microwave background. It also predicts that our universe is part of a multiverse. Okay, and in particular, there's a form of the theory. It's called eternal inflation, and we also
what's the evidence it provides in that respect?
Okay, so the version of the so how does inflation
No.
multiverse?
That's not my
So
question.
what was your question?
You said your theory predicts X, Y, Z, yeah?
Yes.
Okay. So what we've unpacked is your evidences for the fact that, for example, there could be inflation, or your proposed understanding of inflation, yeah?
Yes.
That's what you've shown the evidence for, or, in this thing that, to be honest, it's over my head.
Okay.
It's 0.96 thing.
Well, we made a documentary. I suggest you watch it.
I'll watch it. But
watch Before the Big Bang, episode 4.
But I'm just
Eternal
saying,
Inflation of the Multiverse. Just Google Before the Big Bang skydive field and you'll see it.
Yeah.
And
So
you'll see the interviews with the scientists.
what I'm asking you now is, what are the tangible evidences that you have of an existing multiverse, and why do you believe it's an existing multiverse?
Well, first of all, I'm not sure that the multiverse exists. It might not exist.
That's our
I'm
point.
saying is the evidence so far is certainly suggestive. It's not.
Can the evidence change?
And how many,
Yes, of
how
course.
many universes would there be in the
right,
multiverse?
I want to know why the Kalam argument is
It would be a very large number, possibly infinite.
No, hold on.
No, but
sorry.
see-
Now this is where you move
Yeah.
really quickly from a scientific discussion to not only a kind of religious scientism that you've made up,
We
but a kind
haven't
of
just made this
vague
stuff
philosophy.
up. This is a mathematical
hold on.
implication of the theory.
No, hold on, man. You just said a big number,
Yes.
possibly infinite.
Yes.
Okay. First of all, there's a mathematical problem with using the word infinite. Yeah?
Oh, what's the mathematical problem?
Okay. I mean, I'm sure you're aware of it. I mean, this is your field.
doesn't exist.
Go on.
I mean, you've heard the examples given by mathematicians of. Ali, tell them, man.
Well, basically, the infinite doesn't exist in the real world.
How do you know that?
It doesn't. How?
How do you know that?
How does it
Tell
exist?
them, Ali, man.
I don't know that it exists.
No,
I never
no,
said it
how
does
could-
exist.
how
I
could-
said it might. I don't know.
No.
You're the one that says it doesn't.
How does infinite exist?
I
No,
did-
but what we're saying is, how does it
Okay,
exist?
how would the multiverse be infinite? Is that what you're saying?
That's not. We're saying infinite doesn't exist in the real world.
How do you know that?
It doesn't. How? Can you show me the number infinite?
Phil, they
Okay,
don't really
why?
know, but what they're basically
No,
saying...
please don't
is
say that, Rob.
actual-
Rob, you can't say you don't know.
No.
We're asking a question here.
Because he's asked you, you can't respond.
Infinite doesn't. No, we did. We're asking a simple question. Does infinite exist in the real world? Where are you getting? You're saying things, but we're saying where you get. Like, for example, let me give you an example. If there's no, how can I give you an example? Yeah.
Yeah, go on. Give us your proof. That
I don't know.
it
I'm
doesn't
just
exist. Because it'll be a revolution.
we just want to know.
No, sorry.
Yeah.
When you said that, I can't tolerate that.
Okay, go ahead.
Because now you're using. Let me tell you why. Yeah. You're saying it's a revolution in mathematics.
Yeah.
So who was Hilbert?
David. Okay, yeah, I'm familiar with the concept. I know where you're going to go with this. Yeah.
What you've done there is you've deceived the public.
No, I haven't.
You have.
No, can I tell you why?
You've deceived the public.
Go ahead. You go ahead.
No,
I'll explain why.
Let me explain why you've deceived the
Yeah.
public. You know who David Hilbert was?
Yeah,
right?
I know who
Alright,
David
fine.
Hilbert was, yeah.
What was his paradox?
It's not a paradox
What
specifically.
was
You're
his-
talking about the
what-
Hilbert Hotel.
Okay, what is it? Well, tell us about the Hilbert
Okay,
Hotel.
so the Hilbert Hotel basically says you can have an infinite number of guests in an infinitely big hotel.
No, that's not what. See, look, when it comes to advancing it, you've got to be ingenuous here, man.
I am being genuine.
No. Let me tell you how you'll be ingenuous, yeah? We've
Disingenuous, I think is what you meant.
No, I'm talking about ingenuity. This is how
Okay.
to be ingenuine,
Right.
not disingenuous.
Yeah.
All right, then this is a word in English. Check out the dictionary.
I'm Scottish, man. I don't know what you're talking about.
I think it
Numbers were infinite anyway.
No. Hold on. David Hilbert, yeah?
Yes.
Okay, he was regarded, just because you quoted.
Yeah, he was a great mathematician, no question
Not
about
only that, he was regarded as probably one of the best of his time, yeah?
it. Yeah, sure.
All right.
Sure.
He
I agree
said,
with that,
and
yeah.
by the way, the majority of mathematicians today agree with David Hilbert. He said he gave the thing that you just kind of, swept by, the hotel paradox is, he says that imagine in a hypothetical world you have a hotel which has an infinite amount of rooms, yeah?
Yeah.
Let's do this slowly, not just brush these things aside. Imagine you have a hotel with an infinite amount of rooms. And then, you know what I'm saying, some people come in, some guests they come in, and they ask, can we be hosted in this hotel? Now, the paradox is, if you say you've got infinity, plus 1, that's a contradiction.
Yeah.
So give us some more
No,
examples.
it's not. No, hang on, you're wrong. You're